I want to go over some of these, even if you haven't necessarily finished them. The first thing you need to know is that 1C is not something that I expect you to just go, I kind of don't really know how to do this, but I'm going to just not really figure it out because it's probably not real important. 1C is essential. 1C, this problem is a basic type of residual problem that you should know how to do. So let's go over it. Here it is. One of the men who participated in this study had a waist of 35 and 10% body fat. That is actual data for an actual observance. Okay, that's important for you to make that connection. Therefore, this guy actually had a waist, which is an X value, a waist in inches of 35%. Body fat was the Y variable of 10%. In order to find a residual, you have to be able to do actual minus predicted. Well, I've got the actual information. It gave me the actual information in the problem. What I don't have is the predicted information. And I need the predicted value at that same X spot. So how do I get what's predicted at an X value of 35? Plug 35 into the prediction equation. Okay? So essentially, if you were to look at a picture of what's happening, then here's what's going on. Here's the prediction line of the waist size. Here is X equals 35. I will plug 35 into the equation and come up with that value right there. And that value is 16.77% body fat. After I do that, I realize that his actual value was right here at 10% body fat. So then I can tell what this residual is. His actual minus predicted is negative 0.677%. So he is 6.77% below the percent body fat that's predicted for him. Okay? All right. Number 2, questions on that one. That is a pretty standard type problem. You really need to know. There's another one I'll show you here in a minute. See if you catch on. Number 2 on these was to see if you could identify where the standard deviation of the slope and the standard deviation of the residuals are. It's important that you can identify their locations on printouts. We're going to actually talk about what those things mean in concept today. Number 3, also the same thing, equation, standard deviation of slope, standard deviation of residuals, there's your R value, and so on. Okay. To number 4, you put these things in where the explanatory variable is your fat grams, which we're attempting to predict or have a relationship with the calories. Okay? So I'm going to kind of skip this part right here. I know you've kind of collected some of that data that you got from your calculator, one variable stats, all that stuff. Okay? Please make sure that you are proficient in defining what the slope means. The slope of 8.17 means that for every 1 gram increase in fat, calories go up 8.17 on average, or you could say they go up about 8.17, that's a U, 8.17, okay, about 8.17. Okay, so there's kind of the highlights on that one. This next one at the top of the next page is almost identical to the one I just went over with you on 1C. You have to be able to compute a residual. So let's do this. First of all, in order to compute a residual, you need an actual value and you need a predicted value. So, if they tell you that 35 fat grams, what is that indicating that 35 is? That is your X value. and that's the actual x value. So let's go plug that in and see what's predicted. Okay, so here I'm going to plug 35 into the prediction equation, and I get 610.28 is the predicted amount of calories if you have 35 fat grams in that food. Okay? All right, so there you go. Got that going on. Where did I come up with this actual? The chart on the previous page. Right here. See this? This is your actual data, and so at a fat grams of 35, there was actually 590 in that particular observance. So therefore, actual minus predicted is negative 20.28. So it is 20 calories below expected. What actually happened was 20 calories below expected. Okay. Now, finally, you did not do number 5. And there was a reason I did not have you do number 5. And it's because it is review, and it involves another formula that I have to kind of refresh your brain about. Okay? I'm pulling back stuff from October and November during this whole chapter, and this is something we have learned before. So let me draw your attention to it. Okay, on this problem, Becky's parents have kept a record of her height since she was born, and so all the information we get is the average of her age and the average of the height. So I've got an X bar, which is the average of the age, and a Y bar, which is the average of the sample, okay, for her mean height. And then look here, we have the corresponding standard deviation. So this is the standard deviation of age, which is standard deviation of X. This is the standard deviation of Y. Now we also actually have been given this information here. And if we had not been given the information that the correlation is 0.86, then we could not do this problem. Okay, now, I did not pull this highlighted yellow formula out from the middle of nowhere. It is located on your formula chart, and I want to show you that really quickly. It is on the laminated yellow formula charts that I have in my class. This is the AP Stats formula chart. On the front page, we do not use much of the left column at all. In fact, this may be the only piece of information that's important on this left column. So if you take a look here, we pretty much never use all this. This is a bunch of extensive formulas, and they give it to us because we actually kind of reference some of them whenever we were first learning the concept, but then the computation is too intense, so then we let the calculator do that so we don't get caught up in the math and miss sight of the actual idea.
What's the first one?
Okay?
3. Standard deviation Y.
Is that Y?
Y.
I don't know, I can't tell. Okay, well, let's not do that right now. Here is, okay, here's the potential only ones that you need to know on the left column. Predicted Y, right here. Predicted Y is slope, oh, I'm sorry, that's y-intercept, plus slope times x, okay? So that one's like y equals mx plus b, no biggie. This one has to do with finding the y-intercept. You pretty much don't need that one either. You kind of know the process for this one and this one from memory. Here's about the only one that I think you need to be able to locate on this chart. That isn't something that I anticipate you having to have memorized. This is the formula for slope. When you are given the variability in the y, the variability in the x, and the correlation between the two variables. And that's what we have in this problem. Okay? So, whenever I look at this one right here, I'm going to use that formula, which is the slope. Right here, slope is standard deviation y over standard deviation x times the correlation. I have actually done that for you right here, and I have done the math, plugged it in, did the math. Here is the slope. All right. Now, Next question, how do I take this one step further and get the equation of the least squares regression line? What do I have to have besides a slope?
Y-intercept.
I need a y-intercept, okay? Well, they don't tell me the y-intercept, but they actually have given me something else I can use. Because this mean of y is not the y-intercept. But,
We plug it in the equation.
aha, good. You can plug in these two pieces here into y equals mx plus b because, you ready? Here's the important piece of information. The mean of x and the mean of y is always a point on the least squares regression line. The mean of x and the mean of y is always a point on the regression line. So therefore, what I have is the slope and a point, which is 44,82. This is a point on the line. So I've got a point, I've got a slope, and now you can use y equals mx plus b. Okay, do you remember that algebra skills? Plug in your mean of y for y. Plug in your slope. Plug in your mean of x. And b is the only thing missing, which is the y-intercept. So you algebraically solve, and you get what the value for the y-intercept is. Okay. Questions there. Then you have the equation. If you did the algebra, you'd get 63.75 for the y-intercept. And so, therefore, here is the end result of the equation. Okay, here's the, oh, that covers it up. Okay, here's the end result of the equation right there. Predicted height, 0.4148 age, plus 63.75. Okay, I think this one is just an interpretation of the slope. But here's another little factoid that you might have forgotten. What happens if you change the scale from inches to centimeters? How is that going to affect the correlation? This like connection of how the dots are around the line. It stays the same. Good job. This correlation is not affected by transformations. This is a little fact that we learned before. So I'm continuing to pull back these things, you know, in light of our review sessions that are upcoming. Other than a positive to a negative direction, you can't change correlation without changing one of the points. It's still 0.86 just because you change the scale. If you multiply, if you divide, if you add, if you subtract, if you flip-flop the x and the y, the correlation value doesn't change. All right, so there's the end of that. So I want to quickly go over those numbers 1 through 10 on your name the test and interval that you just got stamped for. Okay, let's go over those, make sure you're on the right track for that.